Okay, students, after a long time, I am doing this topic. The today's topic is gravitation. So this gravitation is basics, fundamentals of this gravitation. How to find out acceleration due to gravity value. Finally, we find out that acceleration due to gravity value. All we know that acceleration due to gravity value 9.8 meter per second square. So how that value is arrived and how that value is found out. End of this unit we can found out that value. So before that we need some concept to arrive at that value, so that we can learn some concepts before that value find out. First, this is the universal law of gravitation. Universal law of gravitation. This is proposed by the Newton. So one more thing. So this the unit is most important for 10th class and junior inter and the students those who are preparing for NEET and JE mains and advanced. These are basics. I am teaching in basics. These are most important. So these things are useful to these section of students. Okay. So if you see this statement, definition of this universal law of gravitation, the gravitation force of attraction between any two particles is directly proportional to the product of the mass of the particles and is inversely proportional to the square of the distance between the particles. The direction of the force is along the line joining the two particles. This is the statement. This is the statement. So what we can understand here, in this universe, if there are different objects are there. Any two objects, there is a attractive force. There is a attractive force. So therefore, let us assume if you take the one particle here, this is the another particle. This particle name is, let us say A. This particle name is B. A particle mass equal to, let us say M1. B particle mass equal to M2. These obviously the attractive force is there in any two particles in this universe, any two particles. So that force we can find out. So let us assume that F force is acting in this direction because these two particles, let us assume these two are attracted by that some force. So that force is acting in this direction. This particle is attracting this particle with the F force. This particle is attracting this force. This particle with the F force. The distance between these two particles, center to center, let us say that R. The same thing I have written here. Let A and B are two particles. Mass A equal to M1, mass B equal to M2, force equal to F, and the distance between A and B are by the law of the gravitation. According to that statement, the force is proportional to the mass of product of mass of two particles, product of M1 and M2. So F is proportional to M1 into M2. Another statement, another line is there. F is inversely proportional to the square root of the distance between the two particles. That is R square. So therefore we can write this equation. F is proportional to M1 M2 divided by R square. M1 M2 divided by R square, or F equal to, if you remove that proportion, we know that if the F is increased, this term to be okay, F is increased, M1, the product of M1 and M2 to be increased, or otherwise the R is to be, R square value to be reduced. Of course, if F is increased, this product, this term to be increased. That is directly proportional. The thing is that what we have to understand, M1 and M2, the product of M1 and M2 is directly proportional to the force between the two particles, and the force is inversely proportional to the square root of that distance between the two particles, so that if you equal, suppose remove that, suppose the F is to be equal to m1 and m2 divided by r square, obviously some another factor is influencing, so therefore I would like to write that another factor is, let us say that G, so that therefore F of the force equal to G into m1 into m2 divided by r square, where G is the universal constant of the gravitation, This is the term is influencing, so this is about the universal law of the gravitation. So G value is already found out. G value is measured in the laboratory by Cavendish long after Newton's depth. After Newton's depth, after long time, the G value is measured in the laboratory by this scientist Cavendish. So he has he found out that value in the laboratory, G equal to 6.67 into 10 to the power of minus 11 Newton meter square per kg square. So now we can see that how to arrive that units. Units G, this is the equation. We know that Newton proposed F equal to G into m1 into m2 divided by r square. From this you can taken out G equal to F r square, you take it to this side, and automatically m1 and m2 come to the denominator, so that this equation is rearranged. F into r square divided by m1 and m2, as the units of F, R, force, distance between the two particles, R, and mass of that two particles, m1 and m2, R units equal to force units equal to newtons, distance radius R measured in meters, and the mass measured kgs. We know that. So therefore, if you simply substitute in the force in place of F, you substitute Newton, R square, distance measured in meters, so that you may substitute in the m into m square divided by mass kg into kg square. So like this we can arrive the units of G. We have been discussing about the gravitation. End of this unit topic, we are going to find out acceleration due to gravity value. So before that, to arrive that value, we need to learn few topics. So already before this we learned, according to Newton's, force equal to gravitation constant of gravitation, mass m1 into m2 divided by r square between the two particles. So the next one to learn the force required for circular motion. So let us assume that this is the circle. You see that first this statement. Suppose you tie a stone at the end of a string and whirl it around in a circle. As the stone moves, the direction of velocity changes continuously. This means that it has an acceleration. As for Newton's second law, the force must be cause of this acceleration. As Newton's second law, F is equal to ma, so the force must be cause of acceleration. Okay, so if you see this, an object moves along a circular path with a uniform speed. A force towards the center must be exerted on it. This force is called centrifugal force, and it acts towards the center of the circle. So what we can understand is all these statements. You take the string like this, one string, you put it one object, tie one object, and if you rotate like this, suppose this is the thing you see here, this is the string, you put it to one object here. Let us say that if you rotate like this, what is the mechanism, what is the happening, how the force is exerted, what is the acceleration, what is the velocity, what is the speed, all these things we can understand here. So the same thing I have shown here. So this is the center, this is the string, let us say the radius, this is the rotating, so this is the object. So therefore it is rotating in a circular path. The speed is same, the speed of this object along this path is same, but the velocity is changing with different in different positions on this path. That we have to understand. The velocity is changing from point to point. Thus not the velocity, of course speed is same along this path of that object, but velocity is changing with respect to position, So if the velocity is changing, acceleration is also changing. So while it is if it is in a stiff condition, if it is rotating like this is the string, that force is exerted by the string towards this center. You can understand here. This is the string, let us say that radius, this is the rotating like this is the object. The velocity is established, developed tangent at this point on this circle, or let us say that this is the normal, this is the perpendicular. This is the, let us say that in case if you assume that this is the normal, this is the perpendicular, or otherwise at this point on the circle it is tangent. In this direction the velocity is established. While this object is rotating moving with the uniform speed along this circular path. So the velocity is changing from point to point, so that the acceleration is also changing. So the acceleration is increasing, velocity is increasing, the acceleration is increasing, the force is increasing. That force in which direction that is acting by the string, that acceleration is increasing in this direction. So therefore the force is also increasing, acting towards the center of this string. If you lose this string, obviously this object is moving in this direction with this velocity along the at this point in the tangent direction, in this direction, that object if you lose that the tight position, unless you lose it, that this object is moving in this direction with v velocity, it is in the tangent at that point. That is the meaning of this force required for circular motion. If you do it, I have already shown you. So this is the object is moving uniform velocity, the velocity uniform speed, different points the velocity is changing, the direction of the velocity is changing. That's why acceleration is changing. That acceleration is acting towards this center. At the same time the acceleration must be causing the force, so that the force is also exerted, but exerted by that string towards the center. For example, you can observe physically, you see that here, you holding it here, you hold tightly, you are applying force here, more force is here, you leave it, it is falling. So that you have to understand, that you have to understand, it is rotating like this string force tightly, the force is exerted, put it more force is exerted at this point. That we have to understand. So this is a force required for circular motion. So from this we can find out the acceleration. From this we can find out the acceleration. While this object is moving like this with the uniform speed at this different points, how the acceleration is accelerated we can find out. Okay, so here you see that acceleration, we know that. So if you see this this diagram, this is the string, let us say that radius, this is the circle, this is the rotating like this is the object, so that what is the acceleration, this object is accelerating it while it is moving along this path with uniform speed at different points. We can calculate that acceleration equal to acceleration of that object equal to at different points v square by r. So how we are arriving that equation? Actually we know that in on a straight line on a road is straight, that the formula is equal to rate of change of velocity acceleration. But in the circular path, that object is moving with uniform speed, the different points the velocity is changing, so that if the velocity is changing, acceleration is changing. If the acceleration is changing, force is changing. So therefore in circular path the object is moving with uniform speed, acceleration equal to v square by r, where v equal to velocity of that object at that position, and r equal to this is the radius, from a radius. How we are arriving in a simple way? So omega equal to d theta by dt, which means that suppose this is the, let us say that this is the little bit, this is the moving like this here, this is the d theta. So this object is coming over here from here to here, let us say the dt time, that omega is equal to d theta by dt, or otherwise another relation is there, velocity equal to, from this also we can find out, or otherwise the velocity equal to omega r. So from this omega equal to velocity by r radius. So acceleration equal to velocity into omega. From this in place omega you can substitute to v by r, v into v by r, so that it becomes r square by v square by r, that we have to understand. So therefore a equal to, I would like to write v square by r, square of the velocity divided by radius. So we know that the force equal to, according to Newton's second law, force equal to ma, so that therefore you can substitute to v square by r in place of a, so that this equation becomes mass into v square by r. So this is the equation, force equal to mass into mass of the object into the velocity square divided by r, and acceleration equal to v square by r. These two formulas are applicable in the object is moving with uniform speed in a circular motion.